Goodman into your heating and cooling unit. Keeps you cool in the summer, warm in the winter. All of that on this episode of Built in America. Well, it means American workers building products with pride and craftsmanship. Workers that are employed in America, companies making money in America, products that are made right here in America. And that's what we do. On this show, we feature products that are built in America. We're just outside of Houston in Waller, Texas, at one of the largest facilities that I've ever been in my entire life. Today we're going to meet up with Joe Campbell. What is he going to do? He's going to show us how Goodman keeps you cool in the summer and warm in the winter. We're going to see how their units are made from start to finish. Joe, how you doing?
Hi John, welcome to the DTTP.
Man, I hear this place is like over 4 million.
Yes it is, it's quite a large facility.
It was Buffalo, New York in 1902 that the first working electrical air conditioning unit came to be. The first home to get an air conditioning unit was Minneapolis, Minnesota, the year 1914. In 1975, HVAC dealer Harold V. Goodman wanted to bring affordable air conditioning to American homes. After acquiring a company and improving the technology, Harold Goodman reinvented the air conditioning and heating systems to be more efficient and more affordable than ever.
John, welcome to the DTTP manufacturing floor. The whole process starts with this coil of aluminum right here.
This is just a big coil of sheeted aluminum?
That's right.
And this is where my air conditioner heater come from?
Yes.
Really?
Every air conditioning system's basically got three main components. We're used to seeing the big outdoor unit that sits on the side of our house, or sometimes it's on the roof, and it's got a big fan on it and then the coil wrapped around it.
Yeah, I know that.
Then inside the house, there's a couple different configurations, but typically there's either an air handler there with an A coil on top or some kind of furnace with an A coil on top.
Yeah.
So in the case of an air handler, the heating and cooling is coming from the outdoor unit with the A coil, where in the case of a furnace, it's providing the heating and the cooling's coming from the outdoor unit working with the A coil.
Yeah, and that's where I change out my filters. That's the part I know about.
That's right, and hopefully with a Goodman unit, that's all you ever do.
Yeah, hopefully so, yeah.
But we're at the furnace line. Now this is a high efficiency furnace,
Yeah.
so this is a bit of a special furnace, and it's got basically two heat exchangers inside the furnace itself. There's a regular tube heat exchanger, but there's also a fin heat exchanger to get higher efficiency, and it all starts right here. This coil gets mounted on the machine right in front of us here.
Let's check that out.
These coils tend to be about 10 to 15,000 pounds.
Yeah.
And it basically gets fed into this machine where it comes in as a coil. It's basically almost like a real thick aluminum foil, and it comes out as a fin. We'll show you over here. This is the output of that process. And there's a lot of science that goes into this fin from the standpoint of creating the spacing and then the features that give us the optimal heat transfer for the part.
So this is actually what's helping provide the cooling and the heating inside of my home.
That's right. That's right.
Now this is just a thin sheet of aluminum with holes in it. How do you?
But it's basically this whole stack that comes together. Put this back. And on this stack, we basically put it in this series of machines over here, and if we want, we walk into the process, and I'll show you how we make it.
And that's how all of this kind of gets married together, so it's just not all flopping around.
That's right. This piece gets married with the tubing and creates what we call the heat exchanger that then gets mounted into the furnace.
Let's go look at that.
All right.
Yeah.
Now, John, what you're seeing here is we've taken the fins and we're adding the heat exchange tubes to it. So he's going to be putting all of the tubes in those holes. It's a very loose fit. You can just kind of slide them right in there. And then once he gets them all in, they'll go over to this next machine we call an expander that actually expands the tubes to create a mechanical interference between the tubing.
Can I touch one?
Oh, yes, of course.
So this tube right here.
This tube right here is sitting inside there, and it'll be expanded out so that we have very good mechanical contact between the fin and the tube so that you get good heat exchange.
Wow. And you're just popping them into every hole right there, aren't you? So can I do one? Hey, that's pretty cool. And this machine expands them so that they stay in.
That's correct. It's a very high tonnage machine that actually presses with what we call a bullet that basically pushes the tube, and as it does, it expands the tube into the aluminum and creates that interference fit.
Oh, and here we go.
Here's one that's already been, and you can see once it's done, it's all mechanically attached now.
Oh, yeah. This all came from that one sheet of aluminum fed into that first machine we looked at.
That's right.
That's pretty cool. So Joe, you keep taking me to these big rolls. Is this another roll of aluminum?
No, this is actually a roll of painted steel, and this is the other part of what that kind of starts making a furnace. This is the beginning of our wrapper line that actually makes the casing that we build the furnace around.
So really, when you think about it, everything is made here, isn't it?
Most of the components in a furnace we make here in-house. Hey John, why don't you load it to the line and we'll get started here.
Now this is starting to look familiar. This is what I see inside of my house.
This is the output of that machine that basically makes the wrapper for the furnace line.
See, who are you? Oliver.
Yeah.
I'm John.
Jimmy.
Can I make this?
Yeah, you can make it.
All right, let's do this. So what, I just throw it up there?
Throw it up there. Grab the blower deck. Hold it like this here.
So this is the blower deck.
The blower deck.
This is where all the air comes through right here. Oh, how cool is that?
Now you want to open that side up first.
All right.
Make sure it's lined up there.
Yeah.
Slide it between there. Go back.
Go back. Now you made this look earlier a minute ago when I was watching it.
Like that. You turn it down. That way so they can put the screws in.
Ah, check that out. Air flows through. This is actually what you see in your house that's delivering cold and hot air. Of course, there's a lot more that goes in this, isn't there?
That's right. This is just the beginning of the process.
This is just the beginning of the process. When did they actually start putting items in there?
Well, we can walk down the line and show you how we put them together.
That's cool. Let's go check that out. Hey, thank you, man.
You got it.
This is quite a process to put all of this together. Everybody, one specific job to make all of this come together at the end. Wow, so this is like ready to go.
Yeah, this is basically a fully built unit. If you look on the other side, there's still the doors that haven't been put on. We don't do that until we get it through the run testers and verify performance, and then we dress it out and package it up for shipment.
So what are they actually doing right over here?
What you're seeing right now is the run test.
So is she actually going to ignite everything and put some gas through this and make sure it works?
Yeah, she'll be hooking it up just like it would be installed in your home and basically testing all the performance of the unit to verify it's operating properly.
So she's just clamping on a gas
Gas
hose.
valve, right. And now the scan she just did, what she's doing there is she's tying that unit to all of the performance that's already come down the line. So as soon as we start a unit, it has an identity.
Oh,
and
really?
all the critical
like its own true identity.
like its own name. And
Wow.
everything that comes down the line, all the critical components are tied to that unit, and then all the performance testing parameters are also tied to that unit. So we have a very good history of what's going on with that unit from the beginning of the line to the end. And if there's any problems,
I see little scan codes on each and every part in there.
right, that's right. All the critical parts all have the codes on it. And then the unit can't get off the end of the line with a proper label unless all the proper components have been scanned in and it's passed all the tests.
So we're basically ready to go into a house.
They've come out of the run tester. All we got to do is put the doors on them and then labels and package them up and get ready to ship to the customer.
So they're going to pop these doors on there.
Pop the doors on and then we're ready to go.
Wow, this is how your Goodman goes from just some steel and some aluminum all the way to the furnace that's going to keep you warm during the winter, isn't it?
That's correct.
That is pretty amazing. Now, I know we've got an outside unit that works with this as well.
That's correct.
So I guess we need to take a look at that, Tony.
All right, let's go head over to your side of the plant.
awesome.
I'll show you.
I might just keep this, put it on my wall at my house. My little Goodman trophy right there. Joe, you brought me to another roll of steel.
Yeah, this is where we start the fabrication of the sheet metal components for the outdoor units.
Oh, really?
So what we're looking at now is the louver line that actually produces all the louvers.
Oh, so when I look at my outside unit and I see all those louvers.
Exactly.
This is being
So
made
it's
right
all
here.
of the wraparound that goes on. It starts with the steel, it goes through the press,
Oh, wow, look at
and then you get a finished louver coming out the other side.